welcome. In this video, we shall discuss about the electric field intensity due to an electric dipole at an axial point. We are going to see the mathematical derivation of the formula for the same. What is an axial line? An axial line is a line joining the centers of the two charges forming an electric dipole. So we know that an electric dipole comprises of two charges of equal magnitude but opposite nature separated by a distance. Let us look at the diagram. Here we have plus q and minus q charge forming the dipole placed at point B and A respectively. They are separated by a distance 2a. So this system forms a dipole. Now we join the two charges by drawing a line and we extend it on one side. Our aim is to find the electric field intensity at the point P marked on that line. This horizontal line that passes through both the charges is known as axial line, and the point P lying on that line is called as the axial point. So we are going to see the equation for electric field at point P. The length of the distance of point P is always taken from the center of the dipole. Thus, we have marked the midpoint C and we have taken R as the distance of point P from the midpoint of the dipole. Now, let us write the equation for electric field intensity at P due to each of the charges. When we know that electric field is given by E is equals to kq by r square. Here, the distance needs to be considered. When we write the equation for the positive charge, the distance would be r minus a because we are considering the distance bp, and for the negative charge the distance to be considered is ap, thus it is r plus a. These mathematical facts we use and write the equation. The electric field intensity at P due to charge plus Q is E is equals to 1 upon 4 pi epsilon naught Q upon Bp square I cap. I cap gives us the direction of the electric field, which is here towards the positive x-axis. So we get equation 1. Similarly, we write the equation for electric field due to negative charge, that is minus Q. Here the electric field is acting in the opposite direction, thus we write the direction with minus I cap, which indicates the field is acting along the negative x-axis. With these equation 1 and 2, we write the net electric field. For this, the principle of superposition is used. The net electric field vector E is given by the sum of the two electric fields. This is the vector sum of the two electric fields. Thus, we substitute the equations from 1 and 2 and solve it. The method that is used here is taking the LCM or cross multiplication. We have also used the identity r plus a whole square. For this, the identity used is a plus b whole square, that is a square plus 2ab plus b square. For the other term a minus b whole square, the expansion is a square minus 2ab plus b square. So we use the identities and we simplify. We see that 4 terms get cancelled out in the equation, that is r square minus r square, a square minus a square. We are left with the equation 1 upon 4 pi epsilon naught q into 4ra upon r square minus a square whole square into unit vector I cap. Now, in the numerator, we find q into 2a, which is nothing but the electric dipole moment. So, replacing it by p, the small letter p for electric dipole moment, our equation becomes 1 upon 4 pi epsilon naught p into 2r upon r square minus a square whole square unit vector I cap. This is the equation for electric field intensity in vector form. For a short dipole, where r is very greater than a, we neglect a and our equation gets reduced to E is equals to 1 upon 4 pi epsilon naught 2pr upon r raised to the power 4. Cancelling the r, we have E is equals to 1 upon 4 pi epsilon naught 2p by r cube. This is the equation of magnitude of electric field at an axial point due to a dipole. Thank you. For queries in physics, log on to www.rupaliday.com.